When I first learned about OLAP cubes several years ago, one of the things that impressed me the most was the ability to create hierarchies on dimensions, such as date, product, and store. For example, there are natural hierarchies for dates, year, quarter, and month, for example. The product dimension often has one or more natural hierarchies as well, such as product category, product subcategory, brand name, and individual product. And the store dimension typically has at least one geographical hierarchy, such as continent, country, state province, and individual store. The real benefit of these hierarchies is that when you add them to a pivot table, you can drill down. For example, you can begin by viewing yearly totals, then drill down to quarterly totals, and then monthly totals. Fortunately, you can do this in PowerPivot as well. This is not surprising because, as described in the companion video, Cube Functions in PowerPivot, the pivot tables you create in PowerPivot are really based on OLAP cubes. You don't actually see them, but they are created behind the scenes. Therefore, hierarchies can be created and used in PowerPivot just as in OLAP. Better yet, it is extremely easy. I will illustrate with the same PowerPivot data you have seen in other videos. To create a hierarchy, you need to be in diagram view in the PowerPivot window. I will first create a date hierarchy by clicking the Create Hierarchy button at the top right on the Dates table. I get a generic name, which I will change to YQM for year, quarter, and month. It helps to maximize this table so that I can see more fields. Then I will drag the year, quarter, and month fields to the hierarchy. Note that the order matters. Essentially, you want to begin with a big picture, year, and move down to finer grained details, months. Next, I will create two geography hierarchies to illustrate that it is possible to drill down in slightly different ways. One will be continent, region, country, and city, and the other will be continent, state, province, and city. Next, I will create a product hierarchy. I want this to go from product category to product subcategory to brand name to product name. Unfortunately, the first two of these are not in the products table. The product subcategory key field is in this table, but I want meaningful names. Fortunately, because the tables are related, I can use the DAX related function to create the names I want in the products table. Now I can create the product hierarchy. Finally, to show what I mean by drilling down, I will use the pivot table I have already created. It currently shows the total sales amount. I will perform some sample drill downs on the hierarchies I've created. Just watch. Here is the date hierarchy. Here is the first geography hierarchy. Here is the second geography hierarchy. And here is the product hierarchy. I think you can now appreciate what a useful feature this is. This video illustrates named sets, a nice feature available in PowerPivot pivot tables, but not available in regular pivot tables. Named sets are essentially commonly used filters. They define the filters so that you don't have to define them each time you want to filter in a certain way. To illustrate one use of named sets, I will use the pivot table you see here. It is based on the PowerPivot dataset you have seen in other videos in this series, and it currently breaks down sum of sales amount by the region country name field in the geography table. If I want to filter by country, I could do so in the usual way, but it is tedious to check or uncheck items from a fairly long list, especially if I have to do this in multiple pivot tables. Instead, I can create a named set of the countries of interest, in this case Western Europe. To do this, I select Create Set based on row items from the Fields, Items, and Sets dropdown on the Analyze ribbon. By the way, if you try this with a regular pivot table, you'll see that this option is there, but it's disabled. Then in the New Set dialog box, I give the set a name, and with the arrow pointing to any country I don't want in the set, I click the Delete Row button or press the Delete key. This is actually pretty fast because the pointing arrow keeps moving down the list as I press Delete. If I delete a country by mistake, I can click the Add Row button, find the deleted country, and add it back. At the bottom, I will keep the All item. This produces grand totals. Note the bottom checked option. If you leave this checked, as I will, the current rows field will be replaced by the new set. When I click OK, I see that only Western European countries are listed, and I see a new group in the PowerPivot Fields pane, Sets, with my new set checked. In terms of the pivot table, this set acts just like any other field. However, there is one problem, the grand total. It is for all countries, not just the countries in my set. I can change this through the Pivot Table Options dialog box. Under the Totals and Filters tab, I need to uncheck the Include Filtered Items in Set Totals. Then I see the correct total for my set. As another example, I will create an asymmetric report that would be difficult to create without named sets. I will place year and quarter in the columns area and add sum of return amount to the values area. I will also change labels and get rid of grand totals for the rows and yearly subtotals, just to clean it up a bit. Now suppose I'd like a report where I can compare sales total in the last quarter of any year with return total in the first quarter of the following year, with all other columns filtered out. If there is a way to do this without named sets, I'm not aware of it, but it's easy with a named set. When I open the New Set dialog box, now based on column items, you can see that the choices are combinations of year, quarter, and values, and I can select any combinations I want. There are only two complete comparisons, for 2007 to 2008 and 2008 to 2009, and I'll keep only these. Again, this named set has been added to the PowerPivot Fields pane, and the resulting pivot table shows exactly what I want. Also, the grand totals at the bottom are correct because the option I changed earlier for grand totals is still in place. One last thing about named sets is that you can manage them from the Set Manager dialog box, again available from the Fields, Items, and Sets drop-down list. From here, you can create a new named set, edit an existing set, or delete one or more existing sets. This video illustrates how you can create KPIs, or Key Performance Indicators, in a PowerPivot pivot table. A KPI is an indicator, often a visual indicator, of how entities such as stores or sales reps are doing in terms of reaching quotas or targets. The KPIs in PowerPivot aren't very fancy, but they can be quite useful, and they are fairly easy to create. I will again use the PowerPivot data you have seen in other videos in this series. In the sales table, I have already created two calculated columns, net revenue and target. Net revenue is straightforward, sales amount minus total cost minus return amount. The target column provides an optimistic target for the net revenue. It uses the DAX round and rand functions, which behave just like the same functions in Excel, to generate a random value between the net revenue value and 150% of the net revenue, rounded to the nearest $100. Normally, a company would set targets according to some policy, but I have generated these random targets just for illustration. To create a KPI, you select New KPI from the KPIs drop-down on the Excel PowerPivot ribbon. If you are used to PowerPivot for Excel 2010, you will notice that this is different in Excel 2013. As with calculated fields, KPIs are now clearly part of the PowerPivot data model, and they are not dependent on the presence of any pivot tables. However, before you create a KPI, you have to create at least one explicit calculated field. This will be the base field for comparing to the target. In this case, it will be the sum of net revenue, which I will now create along with format. As soon as I create this calculated field, it is automatically added to the pivot table, if there is a pivot table, in the values area. If you plan to compare this calculated field to an absolute standard, that is, if the target is a fixed number such as $100,000, you can create the KPI now. However, if you plan to compare the base field to another calculated field, you have to create this calculated field as well. For this example, it will be the sum of the target column. Again, as soon as this calculated field is created, it is automatically added to the pivot table. Now I will create the KPI. In the KPI dialog box, I have to specify the base field and the target field. The base field is total net revenue, and the target field is target total. Next, I can change the icons and the cutoff percentages. By default, for example, if the base is within 80% of the target, it's colored green. I will use these defaults. A new status field is added automatically to the pivot table. When I look at the sales group in the Fields pane, I see the KPI icon next to the total net revenue field. When I expand this, I see 3 checkboxes. For a reason I don't understand, the status option is checked, but it doesn't show the icon I'd like to see in the pivot table. However, if I uncheck it and then check it again, I see the red, yellow, green icon. I can also check the goal option to see the goal. To test it out, I will see how the company's stores are performing against their targets. As you can see, the good news is that none of them are in the red. The bad news is that there are quite a few not in the green. Again, remember that when you create a KPI, you first have to create at least one explicit calculated field as the base. Optionally, you can also create a target calculated field to compare it to. This video discusses cube functions in PowerPivot and how pivot tables built in PowerPivot are related to pivot tables based on OLAP cubes. If you haven't already viewed the companion video, Introduction to OLAP, you should view it first and then return to this video. First, you should realize that the OLAP technology has existed for quite a few years, well before PowerPivot was developed. As described in the companion OLAP video, OLAP datasets stored as cubes are based on dimensions and measures. Dimensions are fields such as customer, product, and store you typically place in the rows, columns, and filters areas or in slicers. Measures are typically numeric fields you place in the values area, such as revenue or items sold. The OLAP technology, developed by various software companies, including Microsoft, even has its own query language for dealing with the dimensions and measures of cubes. The language is called MDX, which stands for Multidimensional Expressions. This brings us to pivot tables in PowerPivot. When you create a pivot table in PowerPivot, An OLAP cube is created behind the scenes, and the pivot table is based on this cube. So PowerPivot draws on much of the OLAP technology, only in disguised form. Fortunately, most users can remain blissfully unaware of this fact. However, here is a consequence. Starting with the PowerPivot data you have seen in other videos in this series, I have already created a pivot table of sales amount totals broken down by a year, quarter, and product category. Now I will use the option to convert everything in the pivot table, including labels and numbers, to formulas. I do this through the OLAP Tools dropdown on the Pivot Table Tools Analyze ribbon. I don't do it from the PowerPivot ribbon or the PowerPivot window. The only PowerPivot role here is that the pivot table is based on a PowerPivot data model. I will convert the pivot table to formulas. Then I no longer have a pivot table. Instead, I have cube formulas, using the cube member and cube value functions that are based on the MDX language. You might not understand these formulas completely, but they are fairly readable. Here is a cube member formula based on the sales amount measure. Here is another cube member formula based on the product category dimension. Here is a cube value formula for a particular sales total. Surprisingly, this conversion is undoable. I'll press Ctrl-Z to convert back to a pivot table, and then I'll create the cube formulas again. Why would anyone want to convert to cube formulas? Suppose you want to change the layout of your pivot table to create a custom report. For example, you might want to add blank rows between years, which you're not allowed to do with a pivot table. One solution is to copy the pivot table and paste it as values. Then you can add blank rows or reformat it in any other way you like, but the cell values are no longer connected to the underlying data source. In contrast, you get the best of both worlds with the cube formula approach. The cell values are still linked to the original data, but you can format the results in any way you like, including the addition of blank rows. Instead of using cube formulas, you can also create a custom report with the getPivotData function, and this applies to regular pivot tables as well as PowerPivot pivot tables. This is described in the companion video using getPivotData for custom reports from the previous pivot tables course. However, after watching that video, I think you'll agree that the cube formula approach is both quicker and easier. This video illustrates a very useful option you can add to your PowerPivot toolkit. It shows how you can add a totally unrelated table to your data model, often called a parameter table, for what-if analysis. As soon as you see one example of a parameter table in action, you will probably be able to think of others for your own applications. I will again use the data model you have seen in other videos. The sales table includes revenues in the sales amount column from these sales. Let's assume that there is a sales tax on these sales, and the company wants to find the total sales tax broken down in some way in a pivot table. However, the tax rate tends to change, so the company wants to do a what-if analysis on possible tax rates. The first step is to add a table to the data model. This is the parameter table, and it will simply contain a list of possible tax rates. An easy way to add this table is to create a column of tax rates in Excel, copy it, and use the copy-paste method of adding a table to the PowerPivot data model. Here is my list of tax rates in an Excel worksheet. I will copy this list, click Paste in the PowerPivot window, and provide a name for the new table. The new table is unrelated to any of the other tables, as you can see in diagram view. But this is fine. There is no requirement that all tables in a PowerPivot data model must be related. Besides, there is no natural way this table could be related to other tables. The second step is to create a calculated field for total tax. I will do this in the calculation area of the sales table. I have already created a revenue calculated field, the sum of sales amount. The new total tax calculated field is then revenue multiplied by tax rate. Unfortunately, this produces an error. Actually, the reason is obvious. When I use the tax rate field in the formula, there is no way for DAX to know which of the tax rates to use. Besides, the tax rate comes from an unrelated table. I will delete this calculated field for now. And I will show the type of pivot table I plan to use. I might want to break down total tax in the usual way, such as by continent and product category. I have already done this for revenue here. Now I will create a slicer for the tax rate. Presumably, the user will choose one tax rate from this slicer, and this tax rate will then be applied to get the total tax. With this in mind, I will return to the calculated field formula. Conceptually, I want the formula to say that if exactly one value from the tax rate slicer is chosen, this value should be applied. And if more than one value is chosen, a typical rate such as 5.5% should be applied. Of course, I expect the user to choose exactly one tax rate. Choosing more than one wouldn't really make any sense. The formula required to implement this logic is trickier than you might expect, and it requires two DAX functions, has one value and values, you probably haven't seen before. The formula starts with an if function, and then uses the has one value function on the tax rate field to check whether exactly one tax rate has been chosen. If it has, that is, in the true part of the if, the values function is required to return a column of values chosen, in this case the only value, for the tax rate. Otherwise, in the false part of the if, I will use a tax rate of 5.5%. Of course, you can handle the false part in any way you like, reasoning that it will hardly ever occur anyway. By the way, I can always click the Check Formula button to see if my syntax is correct. If it's not correct, I can look for syntax errors. As you can see, total tax has automatically been added to the pivot table, and I can select any tax rate. It's that simple. Note that I get a warning about a possible missing relationship. This refers to my disconnected tax table, and the warning can be ignored. Now that you know that parameter tables are possible and how they can be used, take a few minutes to think about situations where you could apply them to your own analyses. I'd be surprised if you couldn't think of a few.